Hello everyone, I am Harshita and I am from Bangalore Institution of Technology. Today I am going to be talking about T flip-flop. Firstly, let us understand what a flip-flop is. Imagine a light switch. What does it contain? On and off operation, that is all. A flip-flop is like a digital version of that switch, but it can remember its state even when the power is turned off. Okay? So precisely if you want to define a flip-flop, it is a digital circuit. It is a sequential circuit that can store a bit of information, 0 or 1. Okay, it's a fundamental building block in digital electronics used to store and manipulate information in computers. So, what are the applications of the flip-flops? They are used in most of the digital devices. Okay, anything that has the ability to store data or information, the flip-flop is there and flip-flops are used. Examples we can see computers, laptop, digital calculators and mobiles and etc. So they are using every devices that stores information, and yeah, so they are flip-flops are also used in counters, shift registers, and arithmetic logic units. There are four types of flip-flops. First one is SR flip-flop, second is D flip-flop, JK flip-flop, and the fourth is T flip-flop. Let us discuss what is T flip-flops. Okay, let us discuss only about T flip-flop. Let me turn on the pointer. Okay. Here in the T flip-flop, firstly, this part is the circuit diagram and this is the block diagram. Block diagram is nothing but the simpler version of the complex circuit. That is all. There is no magic in that. Okay, so basically if you understand the circuit, you will know how to write a block diagram. Okay, so yeah, firstly let us look into what is in the circuit diagram. Okay, so if you look into the circuit diagram, we observe that it is very similar to SR and JK flip-flop. Okay, so but what is the difference? Here you can see there is toggle. T is nothing but the toggle in T flip-flop. Okay, so T is the input and there is only one single input. But in case of SR and JK flip-flop, we had two inputs. Sorry, two inputs. Yeah, that in case of SR we had S and R as an input, and in JK flip-flop we had J and K. But in toggle we have only one input. Okay, so since it is a flip-flop, we can say we have clock pulse. Okay, then we have the output, that is Q and Q bar. Q is the output and the Q bar is nothing but the complement of the output. Okay, so what all does this circuit contains? One single input, that is T input, a clock pulse and two outputs. Okay, let us understand the truth table. Okay, firstly let me write this formula. Everybody knows 2 bar in. Okay, okay, here T is the input, Qn plus 1 is the output. Okay, understand that. First thing to remember is T is the input, Qn plus 1 is the output. Qn plus 1 is nothing but the next state output. Okay, first thing to remember. Okay, since there is only one single input, we can say what are the possible cases. We can say T input is 1, so n is equal to 1, so we'll get two cases. That would be two cases, so 0 and 1. Okay, 0 and 1. So when you take 1 as an input, let's see what's gonna happen. If you take 1 as an input, we get an output. Assume we get an output 0. Here 0 is the current state. Here I have mentioned Qn, that is nothing but the current state. Okay. So next state output depends on the current state output in the T flip-flop. So if you give T as 1 and assume you get output as 0, then the next state output will be Q1, that is current state output, that is nothing but the 0. Similarly, if you get the output as 1, then the next state output will also be 1, similar to current state output. That is all. Moving on to the next case, assume you have 0 as the input. What will be the output? Assume you are getting the output in current state as 1, then next state output will be the complement of the current state, nothing but 0. 0 is the complement of the current state output. Very similarly, when you take 0 as an input and you're getting, let's say, 0 as an output, then the next state output will be the complement of 0, that is nothing but 1. Okay. Quickly, let's summarize what happened in truth table. Okay. If you take 1 as an input, you are getting current state output as for next state output. Okay. If you're taking 1 as an input, you're getting the current state itself as the next state output. And for 0 as an input in T, the current state will be complemented for the next state output. That is all. What are we getting? If you take Z as 0 as input, we'll get next state output as the complement of the current state output, that is Q bar. Okay, simple, that's it. Moving on, let's understand the characteristic table. This is nothing but the truth table. If you understand the truth table, this is very easy to figure out. Okay. In truth table, we saw two cases, that was T as 0 and T as 1. Okay. So let's add another input, that is current state output. So there are two inputs. So into n plus 2n formula, if there is two input, the n value becomes 2. So 2 power 2 would be 4. So 4 cases are there, 4 inputs are there. Okay. So let's see what happens. When we saw that T, if the T is 0, we should get the output, the next state output as the current state output. Let's see if it is true. So if T is 0 and assume you are getting 0 as an output, current state output, then the next state output is also 0. And if it is 1, it will be 1. So it will be the current state, next state output will be exactly current state output. Okay. In truth table, we also saw the case for 1. If it was the input, we got next state output as the complement of the input. Current state output. Okay. So let's see how is that. Since we took 1 as an input and assume you have a current state output as 0, then the next state output is the complement of 0. Here it is 0, then the complement of 0 is nothing but 1. Similarly, if the current state output is 1, then we are getting the complement of it, that is 0. Okay, to summarize it again very quickly, we can say that if the t is 0 and current state output is 0 and 1 or anything, we can say when the t is 0, the next state output will be exactly similar to the current state output like we saw here. Okay, and if t is 1, we are getting the complement in the previous next state, we are getting the complement of the current state. That is it. There is nothing to scratch your head. If it is 0, the t is 0, we'll say the next state output is the current state. And for t equals to 1, we can say the next state output will be the inverse of the current state output. Okay, moving on to the excitation table. In excitation table, there is no difference from characteristic table. There's absolutely no difference from the characteristic table. All you need to understand is that Qn is taken, and Qn plus, that is current state, and next state is taken as the input instead of t and qn. Okay, here t is taken as the output and qn plus 1 is taken as the input. Okay, so yeah, it is the same cases. If you take 0 0 here, you're getting toggle as 0, and if it is 0 1, we are getting the toggle as 1, and if it is 1 and 0, we are getting the toggle as 1, and if the input is 1 1, we are getting the toggle as 0. Okay, so this is about the excitation table. And moving on to the applications of the T flip-flop. So the first is the frequency division. The T flip-flops can be used to divide the clock frequency by 2, which is useful in digital circuits where a lower clock frequency is required, and T flip-flop can be used to generate pulses at a frequency that is a fraction of the input clock frequency. Next would be the counter, like binary counter. T flip-flop can be used to implement up or down counters, which can count in both the positive and negative direction. T flip-flops can be used to implement modulo n counters, which can count up to maximum value before resetting to 0. And the next would be the shift registers. T flip-flops are used to implement SISO, that is serial in and serial out registers, which can shift data one bit at a time. They are also used in SIPO, that would be serial in parallel out registers, which can shift data one bit at a time and output data parallel. Next is the data storage. They are used in T flip-flops are used in RAM, which allows the data to be stored in the to be stored and retrieved randomly. And they are also used in FIFO memory, which stores the data in a given order or the order that has been received. Okay, then finally it is used in clock signal to generate clock signals, which are used to synchronize digital circuits, and the T flip-flops are used to divide clock signals, which is useful in digital circuits where a lower clock frequency is required. So this was about the application. Thank you all.